Hi friends, my name is Amita and in this video I am going to discuss about one of our important technique of a network analysis, that is a Supermesh analysis. Dear friends, in my previous video I have explained the mesh analysis, which is one of our important technique of a network analysis, and when we apply a mesh analysis to determine the current or a voltage drop or a power loss in any branch of the circuit, first step is we identify the meshes in a given circuit, then we assume the direction of current in each mesh either in clockwise or in anti-clockwise, and later on we write the KBL equation for each mesh. And once we get the equations for the each meshes, we solve those equations and determine the current in a particular branch of the circuit which we are supposed to calculate it. But when the circuit is having the current source, and for current source we are not able to write the voltage term, so such kind of circuits cannot be solved by the mesh analysis. Under the circumstances, we are supposed to take the help of an Supermesh analysis. Now the question is, what is Supermesh? Supermesh is nothing but it's a combination of two or more than two consecutive meshes which are having the current source common. So now my dear friends, without wasting time, I am sharing my screen and will tell you how to apply a Supermesh analysis for the determination of a current or a voltage drop or a power loss by each and every element of the circuit. So let us discuss about Supermesh analysis. Now first I am writing the few important points of Supermesh analysis. It is a technique of network analysis. So as it is the technique of network analysis, means we are aware about the input, we are aware about the circuit parameters, and we are interested to determine the output, that is current, voltage or power loss. It is applicable for meshes and we use Kirchhoff voltage law to write the KBL equations for the mesh and supermesh. The third thing is about Supermesh analysis. This method is used when the circuit is having current source. So if the circuit is having current source, then that circuit cannot be solved by mesh analysis. That can be solved by only Supermesh analysis. Now the question is, what is Supermesh? Supermesh, it is the combination of two or more than two consecutive meshes which are having current source common. For an example, like I am drawing one of the circuit. Now if you see this circuit, let's give the name A, B, C, D, E, F, G, H. Now if you see this circuit carefully, there are three meshes in the circuit: A, B, G, H, A, then B, C, F, G, B, and third one is C, D, E, F, C. Now you can see here, this is mesh 1, this is mesh 2, and this is mesh 3. But if you see mesh 1 and mesh 2, these two meshes are having this 10 ampere current source common. So what is the definition of Supermesh? That it is the combination of two or more than two consecutive meshes. For this particular case, it is the combination of mesh 1 and mesh 2 which are having current source common. So that means in this case, A, B, C, F, G, H, A. That's the combination of mesh 1 and mesh 2. These two mesh combinedly makes the Supermesh. So this is what the meaning of Supermesh. Now if you want to solve the numerical by Supermesh analysis, then the first thing is we need to understand, as I already told you in the beginning, that mesh analysis is nothing but it is the application of KBL to determine the current or a voltage drop or a power loss in any element of the circuit. And what is KBL? KBL is nothing but it is the algebraic sum of a voltage in any closed loop is equal to 0. So let us try to solve one circuit with the help of Supermesh. So let us try to write Supermesh analysis. Now what are the steps of solving the numericals by Supermesh analysis? Let us write steps. The first step is identify the meshes and supermeshes in the circuit. Second thing is name the nodes of the circuit. Then assume the current in each mesh, but either all are clockwise or anti-clockwise irrespective of voltage source polarity. So whatever the voltage source polarity is there, you need not to take care. Only randomly we are supposed to take the direction of current in each mesh, either clockwise or anti-clockwise. So let us try to solve one circuit. Supermesh analysis. One more thing, irrespective of voltage polarity, and the fourth thing is, and the fourth point is write the KBL. Now let us try to understand Supermesh analysis. How to approach a numerical when we use Supermesh analysis. So first I am writing the steps that are supposed to be followed. Step number 1, name the each node of the circuit. Then the second thing is identify the meshes and supermeshes in a circuit. The third thing is assume the direction of current in each mesh, either clockwise or anti-clockwise, irrespective of voltage and current source polarity. Then write the KBL for each mesh and supermesh. Okay. Then solve the equations to determine the current or voltage drop or power loss in any branch of the circuit. Now let us solve one numerical that will be clear to you how to apply the Supermesh analysis. So I am telling you with the help of one numerical. I am taking one DC circuit, 10 volt. This is 5. Here it is 5. This is 10 ampere. This is 10. This is 15. This is 5. And this is 10. Suppose this is the circuit. So what is the first step? Give the name to the circuit. So A, B, C, D, E, F, G, H. Now in this circuit you can see there are 3 meshes, A, B, G, H, A, B, C, E, G, B and C, D, E, F, C. But the mesh 1 and mesh 2, these are the 2 meshes which are sharing the current source of 10 ampere common. So what is the supermesh? Supermesh is A, B, C, F, G, H, A. And there is a one mesh, that is mesh C, D, E, F, C. Now let us assume the direction of current in each mesh randomly clockwise or anti-clockwise. I am taking clockwise. So I1, I2, I3. This circuit is having 3 meshes. 1 and 2 meshes combinedly makes the supermesh, and third mesh is the separate mesh, that is C, D, E, F, C. Now let us try to write the KBL equation. So when we write the KBL equation for the supermesh, We write the individual equation for mesh 1, that is ABGHA, leaving the current source branch. We write the mesh equation for BCFGB, leaving the current source branch, and then add it. So what is the KBL equation for mesh 1? That is 10 minus 5I1. We will not write for this particular branch as this branch is having current source common. So 10 minus 5I1 is the mesh equation for the mesh 1, that is ABGHA, leaving the current source branch. Similarly, we will write the equation for a mesh 2, leaving the current source branch. So what will be that equation? Minus 10I2 minus 15I2 minus I3. Why I2 minus I3? Because 15 से current I2 is also flowing, 15 से current I3 is also flowing. But when we are writing the KBL for mesh 2, we will assume that I2 is greater than I3. That's why I2 minus I3. And this is the equation for mesh 2. And we are supposed to add this with a mesh 1. And that is equal to 0. So if you further solve it, 10 minus 5I1 minus 10I2 minus 15I2 plus 15I3, that is equal to 0. So this is, now if we further solve it, what I am going to get? Minus 5I1, 10I2 and 15. So that means minus 25I2, then plus 15I3, that is equal to minus 10. So what I am going to get? 5I1 plus 25I2 minus 15I3, that is equal to 10. This is equation number 1. Now when we were writing the equation for a super mesh, we have not written anything for the branch which is having current source common. So for that we are supposed to write the equation for this. When we write the equation for this branch, whenever any current source is in series with the passive element, the current in that element will be always equal to the current source. So this thing is clear. The current through 5 ohm resistance will be 10 ampere only. If this current source will not be here, when we write the current for 5 ohm resistance, we are supposed to write either I1 minus I2 or I2 minus I1. Now I1 minus I2 or I2 minus I1 mein, which one we are going to choose? For that we will see the current source direction. As the current source direction is from downward to upward. So 5 ohm say the current can be only downward to upward when the I2 is higher than I1. So that means we will write I2 minus I2 minus I1. This should be I2 minus I1. So it will be I2 minus I1 is equal to 10. This is equation number 2. So from super mesh we are going to get two equations. One is 5I1 plus 25I2 minus 15I3 is equal to 10. And the second equation is I2 minus I1 is equal to 10. Now we will write the equation for super mesh. The third mesh. We are going to write the equation for third mesh. So what is the third mesh? CDEFC. So mesh 3 CDEFC. So what is the KBL for mesh 3? What will be the KBL? Minus 5I3 minus 10I3 minus 15I3 minus I2. So the equation will be minus 5I3 minus 10I3 minus 15I3 minus I2 is equal to 0. So if I further solve it, minus 5I3 minus 10I3 minus 15I3 plus 15I2, that is equal to 0. So minus 5 minus 10 minus 15, what it will give? Minus 30I3 plus 15I2, that is equal to 0. I can rearrange it. 15I2 minus 30I3, that is equal to 0. This is equation number 3. Now if I write all the equations, all three equations that we got, so what are those equations? Equation number 1 is 5I1 plus 25I2 minus 15I3. 5I1 plus 25I2 minus 15I3, that is equal to 10. This is equation number 1. What is the equation number 2? Equation number 2 is, that is I2 minus I1 is equal to 10. So I can write minus I1 plus I2 is equal to 10. This is equation number 2. And what is the equation number 3? That is 15 I2 minus 30 I3, that is equal to 0. This is equation number 3. Now we are having 3 equations and 3 unknown. Suppose my job is to determine the current in this 15 ohm resistance. Okay. So now we are supposed to solve these equations. So how to solve these equations? What I can do, now we need to solve these 3 equations. What I can do, from equation number 2, I2 is equal to 10 plus I1 I can write and put in equation 1. So when I put this value in equation 1, I can write from equation number 2, I can write I1 is equal to, from equation number 2, I can write I1 is equal to I2 minus 10 and put in equation. So what I am going to get, 5. I1 की जगह I can write I2 minus 10 plus 25 I2 minus 15 I3 is equal to 10. So what I am going to get, 5 I2 minus 50 plus 25 I2 minus 15 I3, that is equal to 10. So that will be 30 I2 minus 15 I3, that is equal to 60. Now this is equation number 4. Now what is the equation number 3? That is 15 I2 minus 30 I3, that is equal to 0. This is equation number 3. Now solve equation number 3 and 4. So what are the equations? 30 I2 minus 15 I3, that is equal to 60, and 15 I2 minus 30 I3, that is equal to 0. This is equation number 3. This is equation number 4. Now to determine the value of I2 and I3, multiply equation 3 by 2 and subtract from 4. So what I am going to get, 30 I2 minus 15 I3 is equal to 60, and this will be 30 I2 minus 60 I3, that is equal to 0, and then subtract it. So this is cancelled. What I am going, 60 में से 15, that means how much I am going to get, 45 I3 is equal to 60. So I3 is equal to 60 by 45. So that is 5 1 5 12, 5 9 45. 3 4 ja 12, 3 3 ja 9. So what is the value? 4 by 3 ampere. This is the value of I3. Now if I put the value of I3, put I3 is equal to 4 by 3 ampere in equation 3. So what I am going to get, 15 I2 minus 30 into 4 by 3, that is equal to 0. So 10. So what I am going to get, 15 I2 is equal to 40. So I2 is equal to 40 by 15. So 5 8 ja 40, 5 3 ja. So what is the answer? 8 by 3 ampere. This is your I2. I3 is 4 by 3. I2 is 8 by 3. Now what is I1? As you can see here, I1 we have written I2 minus 10. So as we know from equation 2, I2 minus I1 is equal to 10. So what is the value of I2? The value of I2 is 8 by 3. So put the value of I2, that is 8 by 3 ampere. So 8 by 3 minus I1 is equal to 10. So I1 is equal to, minus I1 is equal to 10 minus 8 by 3. So 30 minus 8 by 3. That means 22 by 3. So I1 is equal to minus 22 by 3 ampere. So finally, I1 is equal to minus 22 by 3 ampere. I2 is equal to 8 by 3 ampere. And I1 is equal to 4 by 3 ampere. Now, as in the question, we were able to determine the current in this 15 ohm resistance. So current in 15 ohm resistance will be I2 minus I3 or I3 minus I2. So the current in 15 ohms resistance of the circuit is I15, that is equal to I2 minus I3 or I3 minus I2. Now we know that I1 we have determined minus 22 by 3, I2 we have determined 8 by 3, and I3 we have determined 4 by 3 ampere. Okay. Now the sign which is coming with the current, if as in I1 the current sign is coming minus I1, it means the randomly current direction which we have chosen in mesh 1, the actual direction will be opposite to it. So minus direction, whenever it is coming with any current, it simply shows that the actual direction of current will be opposite to the assumed one. So which one is greater in I2 and I3? I2 is greater. So current will be I2 minus I3. So that means 8 by 3 minus 4 by 3 means 4 by 3. So I15 will be 4 by 3 ampere, which we were supposed to calculate it. So I hope now the super mesh will be clear to you. One more example I am taking, that in this particular problem, if you see, the current source was at the middle part of the circuit. There is another variety of a problem when the current source is at the boundary of the circuit. Like for an example, when it is at boundary of the circuit, suppose the circuit is like this, 10 ampere, this is 5 ohms, this is 5, this is 10 volt, this is 15, this is 20, like this is the circuit. Okay, so again the step is same, give the name. So A, B, C, D, E, F. Take the direction of current randomly. I have taken both clockwise. Now in this case, as you can see that the current source is at the boundary of the circuit. So in this case, the super mesh will be A, B, E, F, A. And there is one important thing about the super mesh, about the mesh analysis or a super mesh analysis. In mesh or super mesh analysis, whenever we assume the current in any mesh, that will continuously flow through each and every element of that mesh, it will not divide at any parallel path. Like if the current in 5 ohm is I1, the current in this 5 ohm is also I1, it will not divide at this parallel path. This is how it differs from the KBL. KBL will not be like this. So as the current in this particular mesh is I1 and one of the branch of this mesh is having 10 ampere current source, that means, and I1 direction is similar to 10 ampere current source direction. So straightforward, the KBL equation will be I1 is equal to 10. We are not supposed to write any KBL equation. Straightforward, we will write that the current amount which we have assumed in this mesh, that will be equal to the value of that current source. Now mesh, another mesh B, C, D, E, B. So what will be the KBL equation for this? That is minus 15 I2, minus 20 I2, and suppose this is 5, minus 5 I2, plus 10, minus 5 I2 minus I1, that is equal to 0. So if I solve it, it will be 40, minus 40 I2, plus 10, minus 5 I2, plus 5 I1. So it will be minus 45 I2, plus 5 I1, that is equal to minus 10. So this can be further written as minus 5 I1 plus 5 I1 minus 45 I2 is equal to minus 10. So this is your equation number 2. Now if we want to determine, so what is the equation number 1? Equation number 1, I1 is equal to 10. Equation number 2 is 5 I1 minus 45 I2 is equal to minus 10. Now put I1 is equal to 10 from equation 1 to equation 2. So 5 into 10 minus 45I2 is equal to minus 10. So minus 45I2 is equal to minus 10 minus 50. So that means minus 60 by minus 45. I2 minus the minus cancel, 4, 9. So what is the value? 4.3 ampere. So I1 is 10 and I2 is 4 by 3 ampere. Now suppose the question is, we are supposed to determine the current in this 15 ohm resistance. So what will be the current in this 15 ohm resistance? Current in 15 ohm resistance will be I2. Current in 15 ohm resistance, I15, that is equal to I2. So I15 will be equal to I2, and I2 we have determined, that is 4 by 3. So the answer is 4 by 3 ampere. So this is how you can, so the answer is I2 is equal to 4 by 3 ampere. Now I am stop sharing my screen. I hope whatever information related to a Supermesh analysis, that will be clear to you. Supermesh analysis normally we use when the circuit is having current source, and Supermesh analysis can have two kind of problems. One is when the current source is available at the boundary, then the problem will be solved in a different way. Another variety of question when the current source is available at the middle part of the circuit, then we solve the circuits in a different way. I have solved the circuits of both types. Now you will be able to solve the circuits by Supermesh analysis. My dear friends, if you like this video, don't forget to press the like button. And if you feel that in future, whenever I make such kind of videos related to network analysis, a notification should reach to you, then don't forget to subscribe my channel.